Okay, at great personal risk, I'm going to use my hand, not this hand, to try to quickly do some notes on vertex form. Vertex form is written this way, y equals x minus some number squared, so I've got to have a perfect square plus some other number. And that will actually give me the vertex, which is the bottommost point of a upright parabola, and it will be the h. If this is a minus, it'll be whatever that is, and if this is a plus, it'll be whatever that is. So my vertex will be the hk. So if I had it in this form, if I had this equation, the bottom point on this would be 2 and positive 1. And if I've got it written this way, notice that's not a minus. So I actually would need to rethink about this. Well, this is kind of like a minus 3 there. And this is not a plus, it's a minus 4, so it's like a plus negative 4. So I might have to flip the signs there if it's not exactly in that form. Okay? So in this case, for that particular form, the bottommost point would be at negative 3 and negative 4. And I don't know if that's quite dark enough, but that's the plus 3 is like a minus 3, so it's in the minus form. And then the negative 4 is like a plus negative 4, so once I get the plus there. If it's in that format, those numbers, the minus in front and the plus in front, will be the bottommost point of a parabola, which makes it easy to graph, and it tells us some things about the properties. Now we're going to use completing the square to actually help us put it into vertex form. And we're going to do things a little bit differently. Typically, when we've done this in the past, we've gotten rid of this and moved it to the other side and then kept our equation balanced. We're going to keep it balanced, but we're going to keep it on that side, just move it out of the way, and then we're going to keep our equation balanced a slightly different way. So as before, I'm going to say, well, y is equal to x squared minus x plus some number to get negatives, and I'm going to move that negative 6 out of the way. And I have to figure out, well, what number works there? And so the number that works there is actually, I've got the right equation here. I do have the right equation here. The number that works there is, I'm sorry, I've gotten stuck here. We'll keep going. That's half of that would be 1/2. And squared, so that'd be 1/4. Okay, 1/4. And then that's that squared, 1/2 squared. And then to offset this, normally I would add 1/4 to the other side, but I'm going to keep it on this side and just say, you know what, if I add 1/4 in, I need to take it away too. So those essentially zero either out. Normally I'd add the 1/4 over here, but in this case I'm just going to put a minus 1/4 on this side. All right, so that gives me y equals x minus 1/2 squared, right? Because that's the way we write that in a perfect square form. And out here I got 6 1/4, which I can leave as 6 1/4, or I can change this to minus 25/4. That would work as well. And so it's essentially in vertex form now. I got the minus. So my lowest x point is 1/2. I got minus 25/4, which actually means my highest, my y value there is a positive, negative 25/4 plus negative 25/4, or 6 1/4. So that would be the lowest point on parabola, which I'm going to show you here in a minute. Let me do one more example, and I'm going to show you one more thing. All right, same thing, x squared plus 4x plus 1. I'm going to do the same thing I did before. I'm going to say, okay, well, that's y equals x squared plus 4x plus something. I'm going to move the plus 1 over the side. We know to make this a perfect square, I chop that in half. It's 4. Half of 4 is 2. 2 squared is 4. So that's my perfect square. But if I add 4 in, I'm going to subtract 4 out. And so once again, normally, when we've done this in class, I've done the plus 4 on the opposite side. It's to keep it balanced. This also keeps it balanced. The plus 4 and the negative 4, they just balance each other out because they're basically going to sum to 0. So it's almost like I've separated 0 apart and made it to 4 and negative 4. All right, so this is y equals x plus 4, no, not 4, plus 2 squared plus negative 3. Oh, and I even wrote it a better way that time. Okay, so that's plus negative 3 So in this case, x minus a squared, once again, this is not written in the right form, so I might want to rewrite that. Y equals x minus a negative 2 squared plus negative 3. And now it's easier for me to tell. Oh, minus a minus 2, my lowest, my x value is negative 2, my y value is negative 3, and that once again is the vertex, the bottom point. And then from that, if I wanted to graph it further, what I might want to figure out is the zeros for this, because I've got the bottommost point, but I might want to figure out where it crosses the x-axis, what's called the x-intercepts, or sometimes called the zeros, because it's when x is equal to 0. And to do that, that's simple enough, because x equals 0, or actually where y equals 0. It's where y equals 0. So if I just make y equal to 0 for my second equation here, I get 0 equals x squared plus 4x plus 1. That would be the place at which point I'd get those x values where y is 0 there. I've got it in standard form up here, or sorry, vertex form, so I'm going to rewrite it in the vertex form that I already had. And then I can solve this. So I'm going to add 3 to the other side. I take the square root of both sides. And then I get, all right, a quick change of venue. I got interrupted, didn't quite get to finish this up. So we had x plus 2 equals plus or minus the square root of 3 after we take the square root of both sides. So all I've got left to do to get x alone is subtract 2 from both sides. So I get negative 2 plus or minus the square root of 3. We've actually had this example in class before, and we've shown that, hey, if I want to do the approximation, this is about 1.7. So this is negative 2 plus 1.7, which would be about negative 0.3. And it'd be negative 2 minus 1.7, which would be about 3.7. And the reason I'm converting these is I want to show you what this actually looks like on a graph. So over here, I've got both our functions, or both our formulas that we just had graphed. The first one here is the one we just looked at, and the vertex for that was negative 2, negative 3, so there it is, exactly where it should be. This is in GeoGebra, by the way. You could type it in yourself and verify this. And then notice where our zeros are. Our zeros are, that's about negative 0.3, and this is not quite negative 4, so negative 3.7. So that works out perfectly. And then in our other one we did, y equals x squared minus x minus 6, we had a vertex of 1/2 and negative 25/4, or negative 6.25, and that's exactly where that is. It's 1/2 and negative 6.25. And let me just make sure my focus is good here. And then finally, I didn't work out the zeros for that, but if I had set 0 equal to x squared minus x minus 6, or that in vertex form, it would work out to 25/4 equals x minus 1/2 squared, and then I take the square root of that, so I get plus or minus the square root of 5/2. So it's basically 2.5 on both sides of 1/2, and 2.5 on one side of 1/2 is 3, and 2.5 on the other side of 1/2 is negative 2, and so that works out perfectly too. And once again, there are 2 formulas there that we threw in there. Okay, hope that helps.